grouped frequency distribution. So here's an example of having taken the age data and transforming it into a group frequency distribution. Remember the two elements that I told you are particularly important, where we talk about mutual exclusivity and being exhaustive. Mutual exclusivity means that where this first class interval ends from 16 to 19, the next category begins at 20 to 23. The next category begins at 24 to 27, 28 to 31, right? So they do not overlap. Also, keep in mind that for this particular data set, our oldest person was 54 and our youngest person was 16. The exhaustive point of our key concepts is that the person who is 54 is absolutely included in one of our class intervals. And in this case is the class interval at the very top. And our person who is 16 is also included in a class interval. So that is this person at the very bottom. I actually transformed this data into a data set using I plugged in the class interval size, formulas to be able to determine what an appropriate number of class intervals would be. And I determined that in order to have the most appropriate number of class intervals, I needed an interval size of 4. All right. So that means that there are 4 scores that can be found within each of my class intervals. So how we do this is actually you want to make sure that when you are counting out if you were doing this as part of an assignment or something, counting out that each class interval has the same interval size. So for example, for our first category 16 to 19, we want to make sure that it has 4 scores that fit within it. That is people who are 16, 17, 18, and 19. I know I'm doing this by hand and it seems a little rudimentary to do it that way, but what happens is if you're looking at only the difference between 16 and 19, you might think that you only have an interval size of 3 here. But that is not the case. Remember that it has to include everybody who's a part of that class interval, including those who are 16 and those who are 19, right? So 16, 17, 18, 19. For the next class interval, we have 20, 21, 22, 23, and then each class interval, continues on in that pattern with, an interval size of 4. Notice also that as part of the guidelines, um, each of our class intervals, our bottom most value within, is a multiple of the interval size. The interval size is 4, and each of these class intervals does begin with a multiple of 4. 16 is a multiple of 4, 20 is a multiple of 4, 24 is a multiple of 4, so on and so forth. So I'm not asking you to create them. Just want you to know that this is the process that we would go through in order to try and make more, better sense of the data that we've collected. I also want to introduce you to these ideas of cumulative distributions. It's this idea, but it applies in these two scenarios. Cumulative distributions give us a better sense of the frequency and percentage of a class interval and all class intervals below it compared with the whole data set. Cumulative frequencies are the total number of cases having a given score or a score that is lower. Cumulative percentage is the percentage of cases having any score or a lower score. This might sound a little bit confusing, but I want to, of course, I'm making sure to illustrate this point. So here's what this means. So we have our group frequency distributions. Each of each of our data points of all the ages in our survey are all captured within this group frequency distribution. We've identified the frequency for each of these. Oh, excuse that. And so what this means is for everyone who is aged 52 to 55, what is the frequency of that class interval? So that's a 1, right? That means there is one person who is between the ages of 52 and 55 in this category. Now, we happen to know, because we've already seen the raw data, we've talked about it a few times, we happen to know that that person is 54. However, if we were to take this table, present it to someone that had never seen the raw data before, and we asked them, can you tell me how old is the person in this 52 to 55 age range? They wouldn't be able to tell you. right? Nothing in here indicates the specific data point. It's just telling you where, within which class interval do we find that data. So that's an important distinction to make in terms of understanding how to read these group frequency distributions. So we have one person in this. Excuse me. We have one person in the 52 to 55 range, one person in the 48 to 51 range, and so on and so forth. All right. As far as determining the percentages, you take the number of the frequency and remember that you divide it by n. In this case, our n is 67, and you multiply it by 100. And in this case, I've been able to determine all of the percentages for each of these individual class intervals. So when we are talking about cumulative percentage and cumulative frequency, there is a process by which you can calculate what they are. In order to calculate cumulative frequency, what you want to do is, I'm going to use this pointer here. I'm actually going to use a dark red color just to kind of help make this stand out. So to calculate cumulative frequency, you're going to take your bottommost frequency. In this case, it is 19. Once I say bottommost, regardless of whichever way you've organized your data, whether you've gone, if it's ordinal or interval ratio, you've gone from a top-down approach or a bottom-up approach, the bottommost row is the row that you start with. All right. So in this case, the frequency for that row is 19. We're actually going to carry that right over into this empty column here. We're just going to write 19. To determine then the cumulative frequency for this next class interval, remember that as a definition, we're talking about all the scores in that class interval and those that are lower, which means that we need to be able to add the frequency at that class interval to the intervals that have come before it. So we'll take this 19 and we'll add it to the number 15. And that number is going to pop up. I don't want to say pop up because we're going to do the math here. But we're going to include that in this next empty cell. Okay, so 15 plus 19 is 34. Remember, cumulative frequency is the score at that class interval and all of those below it, which means that we are going to take this 34 and add it to the number 8. 8 plus 34 gives us 42. We're going to take that, add it to the next one up, plus 4. We get 48. 48 plus 6 gives us 54. So this is the idea of being able to determine cumulative frequency. You just add your way up, starting with your bottommost frequency. I'm going to stop, my math there, but let's go ahead and bring these numbers in. So we have 19. Did I do some wrong math here? I might have. 34 plus 8, 42 plus 4. Oh, I think I jumped a little bit. I think I might have gone a little bit high here. So 46 plus 6, 52. Um, plus 5 is 57, so on and so forth. So what you need to make sure is that at the very topmost cumulative frequency is the number that is equal to n. This equals n. So hopefully, if you were doing the math with me before and you thought to yourself, yo, Michael, I think you missed something, then the answer is yes, I did miss something. I did some wrong math there. All right. So that's one great point about why it is. I made it in the last video. Make sure you're doing the math with me, because if we get something different, then let's double check that. So I got something different, double checked it against my own work, and I was wrong. So make sure that you're following along and you're doing the math as we do it. So we have an N of 67 for this data set, and it matches our topmost cumulative frequency. All right. So that's for calculating cumulative frequency. The process for calculating cumulative percent is actually the same. Now we're just using the percentage numbers. So we're going to take our bottommost percentage, which is 28.36, and we're going to add it to 23.39%. I'll just do two of these because as you can imagine, it's a pretty lengthy one here. So 28.36 plus 22.39, which is 50.75. Make sure you include the percentage symbol. We need to add that to 11.94, which equals 62.69%, and so on and so forth, all the way up. I'm going to reveal these numbers. Hopefully, they're the same. Okay, I did that one. So, again, you add all the way up. At the very top, you should get a number that is very, very close to being 100%. Um, we tend to, as scientists, we as social scientists, we write 100% because with rounding, we could end up with slightly different numbers. More often than not, what ends up happening is the one other I guess maybe two other potential outcomes that you could see is maybe on your way up adding, you ended up at 99.99%, or you might have ended up at 100.01%. If you ended up with 99.99%, 100% flat, or 100.01%, you're good to go. And in that topmost cumulative percentage row, you would include only 100%. If you get anything that differs from that, so if you get 99.98%, or if you get 100.02%, then you need to go back and check your math because there was a mistake made somewhere. Those are the only three options that you have for potential answers here. Okay. So I believe that's all that's here for this. Oh no, important conceptual information. This is the last slide for this video. So class limits are the real limits between class intervals. We described them before as being, where one category ends, the next category begins. As a researcher, you may determine that it makes more sense to have flexible class limits, such that the interval sizes are not all equal. And if your rationale makes sense for your question and your data collection, then you, as more or less the owner of this research, it is your prerogative to decide how it is that you want to have differing or more flexible class sizes. As an example, I collected this from one survey where we're being asked to self-select into a particular category, but notice that the number of ages within each of these categories is not equal. Everyone under 21, that's inclusive of people from 0 years old all the way up to 21. And then from 21 to 24, that's just four people, the four, different ages. So again, as a matter of reinforcing that you as a social scientist are the one who has to develop the rationale as to why it is you're collecting the data in the way that you are, you have that flexibility, right? What makes the most sense for your particular research. All right, so that's all I got for this video. Remember that we're talking about group frequency distributions, we're talking about range, class interval sizes, and how it is that we can take that raw interval ratio data and transform it into these grouped frequency distributions to help us reveal some of those patterns.